Hello, this is Mr. Win, and this video is over line segments and the number line. Also a reminder that answers may always involve fractions. For example, if you solve for a variable, let's say x, you might get a fraction answer, and when you plug it in, you might get a fraction for that answer as well. So don't be afraid of fractions, but during this video, I am using a lot of nicer problems that have whole number answers. So unlike a line that goes on forever and cannot be measured, a line segment can be measured since it has two endpoints. That is a starting and ending point. Make sure the notation. For example, here's a picture. Here's M to P. We know it's 5 centimeters. Also, we have line T, but line T goes on forever. So when you see this with the arrows above, that means a full line. That means line MP. We cannot measure that. When you see MP but a line on top without those arrows, it means that's a starting stop point. That's a line segment. We call that segment MP. And when you see the two letters but no marking on top, that actually means the measure of or value of the segment MP. In this case, it's 5. So make sure you know when they're asking for the number, which there's no mark, when they're talking about the segment itself with the line without the arrows, or when they're talking about the whole line with the arrows. All right, another special symbol or marking. If you see this equal sign with the tilde on top, that means congruent. Congruent figures always have the same size and same shape and same angles, but may be rotated in a different direction. But basically, if you could put the two images on top of each other, they would overlap perfectly. So for segments, if two segments are congruent, then they have equal measures. So here, if I say if AB, so segment AB is congruent to segment CD, then the measure of AB is equal to the measure CD. And if I could drag this over and kind of turn it downwards, it would match overlap perfectly. Now sometimes pictures have tick marks. These marks indicate that the segments or sides are congruent and therefore have the same measure. So one more thing is most of the time images are not drawn to scale. The only thing you can trust are the special markings and the math. So here's two line segments. Alright, if the measure of MN is 20 inches, what is the measure of XY? Now they look totally different, but I see this tick mark right here. Alright, that means they're the same. So if MN is 20 inches, XY is also 20 inches. And then remember to always indicate units when possible. If they don't have units, just say unit. But if it says inches, make sure you keep it in inches. If they say meters, keep it in meters. Some more vocabulary. Properties are the basic math rules you've always used. For example, you've used the distributive property. Maybe you remember the commutative property and the social property. We'll talk about those later. Postulates or axioms are math facts or truths, but they never needed proof. Then we have theorems. Those are also math facts and truths, but they do need proof initially, usually from the postulates. Bisect means to divide into two equal measures, and midpoint is the point on a segment that bisects a segment. Alright, so first we have the segment addition postulate. Again, this is like a rule or a fact. Alright, if B is between A and C, then AB plus BC equals AC. The measure of AB plus the measure of BC equals the measure of AC. So here's a picture, should be pretty common sense. B is between A and C. It's not in the middle. Don't ever put the points in the middle unless they say midpoint. So here's the piece of A to B, here's the piece of B to C, and the whole thing A to C. Yeah, if you add this 5 plus 12, you get the full 17. Now if it helps you, you can think of this formula as part plus part equals whole. And also note there can be more than two parts. It could be part plus part plus part plus part equals whole if I divide the whole thing into 4 pieces. But basically you just add all the little pieces to add up to the entire big piece. So here's an example. If points x, y, and z are collinear, with the z between x and y, if xy equals this, yz equals that, and zx equals that, find a and xy. So first let's draw the picture and draw it correctly. It says z is between x and y, so z must be somewhere in there. Alright? If you draw the picture incorrectly, then you'll get the whole problem wrong. So some kids just go x, y, z, and that's wrong. Alright, you label it. Here, using segment addition, we could say the formula, oh, this first piece, xz, plus the second piece, zy, is equal to the whole thing, xy. Alright, I fill it in. The parentheses are there when you plug in for a letter. Check if parentheses matter. There's no distributing, so I can just go to combining, move a to one side, and then get a by itself, and then divide. Alright, so a equals 2. Now make sure you answer the question. Sometimes kids stop early. They say find a and xy. So once you have a, you got to plug in. xy is the whole thing. So I'm going to change the a to a 2. So 6 times 2 plus 7, that's 12 plus 7, that's 19. Alright, so final answer, a equals 2, and the measure of xy is 19 units. Alright, here's another example. T is the midpoint of line segment BS. If BT equals 5G plus 2 and SB, the measure of SB is 6G plus 20, find the measure of TS. So here's a picture. All right, we know BT is 5G plus 2. We know BS is 6G plus 20. Now, we don't have a formula. We have segment addition. We know the first piece B to T plus the second piece T to S equals the whole thing B to S. But we don't know what this is. You can't just put X there. But if you really think about it, don't forget midpoint tells us BT is the same as TS. Always add the tick marks when you see that word. So I added the marks. Now we can fill in this formula. We can say, oh, 5G plus 2 plus another 5G plus 2 equals 6G plus 20. Combine like terms. G to one side. G by itself. G by itself. G equals 4. Alright, now the answer isn't what is G, it says find TS. So I'm going to plug this G into the TS. We know TS is 5G plus 2, so 5 times 4 plus 2, that's 20 plus 2, that's 22. So final answer, the measure of TS, line segment TS, is 22 units. One other cool thing that you should know is when dealing with midpoint, there are other formulas that may work or make sense besides part plus part equals whole, like I use here. Those are, you can double the first piece to get the whole thing, or sometimes even first part equals second part. So for this problem, we could then double BT equals BS, and we got the same answer. Here's another problem. Point A bisects line segment JM. If AJ equals 3P plus 8, and the measure of MA equals 26, find P. So here's a picture. It says bisect, so make sure you put A in the middle. Alright, that's all we have. We can't do P plus P equals W here. But remember, we have the word bisect or midpoint. So we know JA equals AM. So I'm going to add those tick marks. And as long as the same tick marks are good. So you have 2 marks each, or 1 marks each, or 3 marks each. Now I have a formula. I'm not going to use this plus this equals the whole thing. I'm going to use the first piece equals the second piece. So JA equals AM. I fill it in. 3P equals plus 8 equals 26. Get P by itself by subtracting 8. Divide 3. P equals 6. This is find P. That is the answer. There's another good method to solving this problem. If you use common sense, if you know half of JM, the whole thing was 26, and you could double it and say, oh, JM itself is 52. So then we can say JA plus AM equals JM to get 3 plus 8 plus 26 equals 52 and still get the answer P equals 4. So geometry is a lot of fun because you can use any creative method that makes sense as long as you don't break any math rules. Alright, we have a number line. That's just the visual we use for ordering numbers and marking locations. It is only one-dimensional. It goes 2 opposite directions, and it's helpful to think of like the x-axis on the coordinate plane. We can use it to find distances and midpoints. So here's the number line. It goes on forever, but it says -5 all the way to +5 marked. Notice m's at -2 and n's at +2. Question is, what is the distance from m to n? And note that distance is really the same thing as a segment's measure. Now a lot of kids mess up and they add the two numbers together. Alright, if I add -2 plus 2, I get 0. It is not 0 from here to here. This thing, how long is this? Alright, when finding distance, you always subtract and then take the absolute value. Speaking of absolute value, which uses those bar signs, is known as the distance from 0 function. Once there's just a single number inside, that means you must have to combine terms first. It always comes out positive. And remember, distance is never negative. If McDonald's is 1 mile from you, you say you're 1 mile from McDonald's. If you reverse it, you don't say -1 miles. So here's an example. For example, what's the absolute value of -10? It comes out +10. You can also read this as the distance of -10 from 0 on a number line is 10 units. If the inside is very positive, absolute value of +10 is still +10. And here, what's the absolute value of -1 plus 2 minus 3? You have to combine this first to get 2 units. Some kids try to make every number inside positive and they get 6 units. They get it wrong. You must combine like terms first. Once it's a single number, then make it positive. Alright, the formula for finding the distance on a number line is distance equals absolute value x2 minus x1. Just get the two things, numbers, and subtract them. And it does not matter the order. So for example, say m is x2 and n is x1. Here's the formula. -2 minus 2 is -4. Once a single number, it comes out positive. So it's 4 spaces from m to n. If I reverse that, say n is x2 and m is x1. Here's filling the formula. When you subtract the negative, make sure you're not adding. 2 plus 2 is 4, and it stays +4. So from here to here, from m to n is 4 spaces. Alright, fractional distance is a concept similar to distance, but has 2 extra steps. So here's the picture. Notice point A is at -5, point B is at 3. So the question is, find the location of point R if it is 3/4 the entire distance from A to B. We're starting at A and ending at B. All right, here are the steps. Find the entire distance, multiply that entire distance by the fraction, and then add that new number to the original starting location. All right, so first we have to find the entire distance. So we'll do a 3 minus -5, that's 3 plus 5, that's 8, and it comes out positive 8. So we know the whole thing from A to B is 8 units. Now we only need 3/4 of that. We need a fraction of that distance. So we're going to do 3/4 times 8. Hopefully you know to multiply fractions. You make the other thing a fraction. Then you multiply numerator times numerator, top times top, to get 24. Then bottom times bottom, 4 times to get 4. And always simplify. 24 divided by 4 is 6. All right, last step is add that number to the starting location. We're starting at A, so we're going to do -5 plus 6 to get 1. So point R is located at 1. So this right here is 3/4 the entire trip all the way to B. Alright, and then like distance, midpoint, something we want to find as well. Here's our picture. Notice H is at -3, R is at 1. Find the midpoint of HR, line segment HR. So unlike distance, we have to subtract. When you find midpoints, you need to add and then divide 2. Midpoint really is just an average. Alright, here's the official formula. The midpoint on number line is m equals x1 plus x2 all over 2. And really the order doesn't matter here either. So let's call h x1 and r x2. So I fill in the formula. I get -3 plus 1 all over 2. You have to fix the top first. -3 plus 1 is -2 all over 2, which reduces to -1. Alright, so the midpoint would be located at -1. If you think of -1 is 2 spots away from H, and it's 2 spots away from R. It's the middle of both points. Alright, geometric probability is an extension of our normal understanding probability, but using geometric figures. We still do the fraction, what we want, over the total. So here's a picture. P is at -1, E is at +1, R is at +5. If a location is chosen at random on line segment PT, just from here to here, what's the probability that it would land on P to E? Alright, so we just need to find the distance of the thing we want, which is P to E, and the distance of the whole thing all the way P to T, and then divide and reduce if necessary. So the first part, P to E, it's 1 minus -1, really 1 plus 1, that's 2. So the distance from P to E is 2 units. Then we do the same thing for P to T. So 5 minus -1, that's 5 plus 1, that's 6. 6 units. So here is 6 units total. So we want our total, or at the bottom there's 6 total spaces, and we like 2 of those spaces. 2 out of 6, reduce that to get 1 out of 3. Final answer, there's a 1/3 chance of landing on PE, given that it lands on PT. Alright, that's the entire video. Hope you enjoyed it. Make sure you ask questions if you have any. Thanks for watching. See you soon. Bye.